Alright guys, welcome back. We have another question from the third chapter of Mechanics of Materials by Johnston. Question 24. Under normal operating conditions, a motor exerts a torque of magnitude TF 1200 pounds at point F, knowing that the RD is 8 inches and RG is 3 inches. So basically it's the radius for each of these gears. The allowable shearing stress is 10.5 ksi in each shaft. We need to determine the required diameter of the shaft CDE and shaft FGH. So we're dealing with the elastic torsion formula that we talked a lot in this chapter, and basically we know that our shearing stress is equal to torque times the radius over J. Because we're dealing with the solid shaft, our J, or moment of inertia, is 1/2 of pi c to the 4. And if it just plug that J into this equation, 1/2 of pi c to the 4, we can cancel out c. So we're going to have 2t over pi c to the 3, because this question is asking for the diameter. C is radius, so we need to multiply c by at the end by 2. So this c cube is basically 2t over pi shearing stress. So that's the formula that we were going to use, but before that, since we have torque in this formula, we need to figure out the torque for each of these shafts. So the shaft, we can start with shaft CDE first, and for doing that, we need to find the TE, or torque, in that shaft. So we talked about the way we're going to find the torque in each of these. If we look at these two gears, they're going to have the same force applying to each other, same force that are same magnitude. They're just in the opposite direction, so basically they are action reaction. So since the force between these two are the same, and the torque that is applied on each of them, the smaller one is TF and the big one is TE, and this will be our RD, and this will be our RG. We know torque is equal to force times the radius. We know the force is perpendicular to the radius because it's tangent to the circle. It's always perpendicular. So if we want to show TF, we basically have F times RG, and TE is equal to same F times RD. And if we put these F equals, we can figure out that TF over RG is equal to TE over RD. And the question is already giving us this 1200. RG is 3. This is 8. So we can find the torque in the shaft CDE, which is what we need to plug in the formula that we have. So let's just see what we get. So basically it's 400, 8 times 4, 3200, and the unit would be in pound inch. So let's just figure out the radius for the shaft CDE. So C cube is equal to 2 times T, which was 3200 over pi, times the shearing stress. One thing that we need to keep in mind is we need to watch for the units. This is KSI, and KSI is 1000 psi. So we need to multiply that by 1000 because we have pound in the numerator, and we need to be consistent in our denominator too. So psi, or pound per inch squared. So our C would be basically the third root of that ratio that we have, and it's gonna ratio 2 times 3200, and we have pi times 10.5. So the C will be 0.5789, and we just need to multiply this by 2. So the diameter of the CD is going to be 1.158 inches. So that's the answer for the A part. And for the B part, we need to figure out the shaft FGF, or FGH. So our C cube this time, we just have different torque. The torque this time for the member FGH is going to be the TF, which from the question we know is 1200. So we're just going to put that 1200 in here. The rest is the same. 105 0, 0. So let's see what we get for this radius. We just have to put 1200 here. So the C would be 0.4174 inches, and if we just multiply this by 2, that's going to give us the diameter for FGH. If we just multiply this by 2, that's going to give us 0.835 inches. And yeah, the final answer for this question. I hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.